Okay, this is Algebra 2. We're our second day together, and we solved systems where we had x and y. We had two variables, and we solved it. We solved it with elimination and substitution. Today, what we're going to do is take that one step further. We're going to get a word problem, change it into a system of equations, and solve it. Okay, so it's just a little extra step today. You know, we love word problems. Okay, here we go. A caterer is planning a party for 64 people. Okay? When you see a total like that, you know that everything is going to add up. One of your totals is going to be 64. Okay, so that's a total. The customer has $150 to spend. That's another total. That's going to be in your third row. After your equal sign. Okay. A $39 pan of pasta feeds 14 people. And a $12 sandwich tray feeds 6 people. How many pans of pasta? The last line in the word problem always tells you what x and y are. How many pans of pasta? How many sandwich trays should the caterer make? First step, identify x and y. Let x equal, let y equal. Last sentence says what you wanted to answer is the number of pans of pasta. And y is going to be the number of sandwich trays. And the key to your equations are going to be in the totals, because they have to add up to the total. So let's see how that works out. Well, what do I know? I know that $39 times x pans of pasta, every pan of pasta is $39, plus $12 times every sandwich tray is going to equal my total. I want it to equal my total, which was $150 to spend. So this row has to do with a quality. Okay, a quality about whatever x and y are, quality. All right, that's a quality equation. Now I need a quantity equation. What do I know? I know I need to feed 64 people. Okay, so we know that 1 pan feeds 14 people and 1 sandwich tray feeds 6 people. So how does that work? That means that 14x plus what? 6y equals, what was the total number of people? 64. So there we have the number of people equals your total. So notice two things. My equations were based on my totals. Now I just have to solve them. Okay? All right. So this is a quantity equation. It's about how many people. We know what to do with this equation, right? We need to eliminate one of the variables. Let's eliminate the y's, because all we have to do is multiply this by -2. So we multiply by -2, multiply this by -2, and we get, this is just the second, I'm going to keep it in blue. The second equation is changing to -28x minus 12y equals -2 times 64 is -128. Okay? So what am I going to do? I'm going to add these two together. I'm going to just kind of not see this middle row. I'm going to add them together. 39 and -28 is 11x. 12y and -12y is 0y. And 150 minus 128 is 10 minus 8 is 2, 22. Okay, so I changed this row by multiplying it by -2, and then I added it to the top row, and I got this. And what is this? I eliminated this. 0y is just 0. So I know that 11x equals 22. I solve for x. X equals 2. You only have half the equation. How do you get the y? Well, you plug it into one of your equations. So you say 14 times 2, I'm just looking at this equation, plus 6y equals 64. And you solve. 28 plus 6y equals 64. We say 64 minus 28. Okay. 14 minus 8 is 6. 5 minus 2 is 3. 6y equals 36. Y equals 6. Now you have an x and a y and your solution. Let's write our solution. 2, 6. Box it in. Let's do it again. Okay. Hardest part is writing the equation. So do it systematically. Okay. Get your totals. Write your equations. Selling frozen yogurt at a fair. You make $565. Oop, total. And use 250 cones total. Okay, we're gonna, x plus y is gonna equal that and that. A single scoop costs $2. That's gonna have to do with that. And a double scoop costs $2.50. How many of each type of cone did you sell? This is what tells you what x and y are. Let x equal each type. I need number of single scoops. Let y equal the number of double scoops. Remember, your x and y always answer the last question. Now I'm going to set this up in an equation. All right, what has money? This is your quality about the problem. It's about the money. So you have a single scoop. Single scoops are x. $2 times your single scoops plus $2.50 times your double scoop equals $565. We want that, but we also want how many of each type. Now this is a little bit trickier because the only thing, they don't talk anything about the numbers like they did up here. But you want to sell a total of 250 cones. So you say, okay, well, number of single cones plus the number of double cones equals a total of 250 cones. This is a quality equation. This is a quantity equation. Sometimes it doesn't always work this way, but it often does. Okay, now we're going, excuse me, we're going to eliminate. Now I think this would be the easiest to eliminate. What do I have to do? I have to multiply this equation, let's just do it over here, multiply by -2. You get -2x minus 2y equals -500. Don't forget your signs, and you're just going to add it. You're going to carry this across and just add it. This is 2x plus 250y equals 565. Just carry it across. Now you're going to add them together. These cancel. I add those together. 2.5 minus 2 is 0.5y equals 65. Now I can use my calculator and divide both sides by 0.5, and I get y equals 130. And you do that on your calculator, okay? Or you can do it by hand, but there you go. Now we know y, but we don't know x, and always then substitute here. And so you go ahead and substitute. X plus, we know y, 130 equals 250. Okay, solve. X equals 120. And we subtracted 130 from both sides. So there was no trick to that. I just subtracted 130. Okay, now I have the solution to my system. And I always write it as 120, 130. Box it in. Okay? All right. All right, you're going to get into groups after all the notes are done, and you're going to finish these two together. Okay? Work together on that. All right, flip the page over. Let's talk about some qualities about when the systems have infinitely many or no solutions. And I hope that you remember this from Algebra 1. Okay, we're going to solve these systems. What do you want to eliminate? Okay, let's eliminate the x's. What do? If I want to eliminate the x's, I need a -6 here. So I multiply by -2, and I get -6x plus 12y equals -16. I just multiplied through. Now I'm going to just add to this. What do you get? Well, this cancels, and you get 10y equals -7, right? Yes. Okay. Then I feel like I did something. Nope. 10y equals -7. Y equals -7/10. But that is not what I expected to get. What did I do? Multiply this by -2, -6. Oh, that is my problem. When I multiplied -2 by -y, I should have gotten, hopefully you saw that, 2y equals -16. Then when I add, I get 0. There we go. 0y equals -7. 0y is -7. Okay, there's no 10. 0 equals -7. Is that true? No, that is false. So you don't have a solution. No solution. Okay? Sorry about that. Here we go. What are we going to do here? We got to get rid of a variable. Let's get rid of this variable x. Well, what I have to multiply this by to get a +15? Multiply by 5. You get 15x minus 25y equals 30. You add it to this, -15x plus 25y equals -30. It's very similar, but not quite. When I add them together, I get 0 plus 0 equals 0. 0 equals 0. Well, that is true. Okay, it's true, but it's a special case. When you have 0 equals 0, what you have is you have infinitely many solutions. And we remember that what does that look like, right? That looks like two lines, and they're right on top of one another. Infinitely many. No solution is when you have parallel lines. Okay, so let's sum it up. If you get a false statement, there are no solutions. If you get a true statement, there are infinitely many. Okay? All right. Go ahead, try these, see what you get, and if you the answers will be here for you. And then go ahead, go back, get into your groups, and do the rest of the problems. And then there's more practice for you to do for classwork today. All right, hang in there, and I'll see you next class.